thanks for coming and investing your time into this editing. So, some of us are trying to match the deadline for Senegal Symposium, which will be by the end of May. It's very hard to fit maybe the last extension from the editor. And we are chopping the papers in preparation into sections, partially going backwards from conclusions to introduction back. So the papers could be formulated as writing down the conclusions first, and then arranging everything else in papers as minimal necessary set of arguments to support the ideas that are in conclusions. If you will not bring the conclusions, so last time I tried to meanwhile it is not fun. Today we're trying to focus on discussion, and in this section there are it's most creative. It's less standardized, and one can put there several things. So first, well, some people do not have discussion section at all. They wait until reviewers criticize them and then place answers to reviewers' criticism in the discussion section. It's also possible, but we already know that there are very few papers that are accepted without any criticism, and we can prepare safety cushion and guess which criticism can appear toward this research and express it ourselves. This combined with a way to defend possible weaknesses. So do not consider weaknesses of the calculation of the work as your personal weaknesses. It's even if you are a general researcher and you have great best possible tools, best possible methods, and best possible model, it is impossible to make a perfect work. There always will be some strengths and weaknesses, and it is our responsibility to mention them fairly and address them if they are if they can be addressed, or at least to show others how to think about them. So it is a very good help if your work was previously presented at a conference. Most of us traveled to Senegal. Some of us presented seminars recently, and by the nature of scientific communications, you do hear some feedback from visitors to your posters or from attendees of your oral presentations. So there you can see as signatures what in your work induces enthusiasm, healthy jealousy of other people wanted to do the same problem, or aggressive criticism telling that it is not acceptable or highly problematic. So it is a prompt what induces interest in the community, and these questions can be added to the discussion. So if you were recording or memorizing feedback of unbiased audience, it is a best thing just to list what you remember and put your or not to put, but your comments to this criticism into discussion section. Also, you may have your own doubts in your work. It is completely healthy to put it here. If, again, for any research we do, there is a stage of choosing method. Sometimes we use standardized methods and we do not deviate from straight path, but hypothetically one could select one or another method. And it is good to mention that although I have chosen PBE, I could have chosen Visrelip or HSE, or although I used red field theory, I could have used just plain thermocooling rule. with following positive and negative consequences. You do not need to write all the things, only those that seems important to you. Or like I'm discussing experimental quantum dots that are 100 nanometers, and my work is 1 nanometer size. It's a very big approximation to project my results to a realistic system, but there are some common features. So discussion section is a very appropriate place to mention all these things, and things like that, like approximations going towards the limits of applicability happen always, and by the nature of the research, and it is healthy to mention it. Also, some of us do select straightforward description of the results, which is it's not wrong. Like figure 1, figure 2, placed in results, and then in the results section, as we see from figure 1, this material absorbs light. As we see from figure 2, if excited, energy is released. End of results section. Like where some of us select very brief list of facts. If you see that you have missed something that doesn't fit in this straightforward list of facts, one can always add it to the discussion section, as it is most creative thing. And another aspect that one can consider to place there is to interpret the results. So often, nothing here is like written in stone, but formally, if you start writing a paper, it means that you have identified some challenge in the community that you want to address with computation, and before starting computation, you may have developed a possible answer or hypothetical answer how this challenge is addressed, and it's very appropriate place. The discussion section is a very appropriate place to mention if this hypothetical answer was supported, was proved right or wrong with computations. Also, we all are humans, and we develop our opinions. Sometimes you get excited about your results, sometimes you get pessimistic, but you may express it, because results is what it is, but even if results are not perfect, your assessment of their strengths and weaknesses does serve as a traffic light or like street name on a street, as a milestone showing others who exploring similar systems or who practice similar methods, whether this direction is good or not good to go, or which direction one should deviate. So sometimes comments in discussion are most valuable part of the overall paper. So it is not an exam or court case where the author is allowed to live or provided with death sentence. It's more, let's look together on the situation and make a collective decision what anyone who tries to do similar things should do in the future. Okay, and since it is most creative part of the paper, it is really hard to assess and grade. But you may, as we repeatedly again and again play this game when each of us play two roles. One is author and another is reviewer. So reviewer comments, the ones in Big Lives and this mock reviews that we do here, serve really well to authors to improve and find a way how to improve papers. Not necessarily in the sense of results, but definitely in a way how the thoughts are communicated. And while you are reading, you may mention if author if discussion contains the discussion, if the author tries to make abstraction, intellectual abstraction from practical steps to more general trends, from the narrow-minded methods to more general physical picture of what is likely happening in the system. And if also one may identify if author does see any features of the system, any conditions which may affect main result, main trend, either in computation or in experiment or in computation done with different methods, like which approximations or which effects neglected or taken into account are assumed to influence the system. And the list of this practical features can be expanded, and there is no reason to list all of them. In each individual case, it will be very different. Like going to too high temperature, is it reasonable? Is it acceptable? Is it just shorten the time until reaction, or it qualitatively changes the reaction, or the influence of electric field, does it just continuously shifts energies, or it reconfigures overall system, reconfigures shape of orbitals, and it will be a completely different system when one applies electric field. Anything, or how much absence of solvent affects results, because there is a way to computationally include solvent, but we often miss it, so typically it just shortens the energy. So you also may mention if it looks like author did construct the draft of a paper as hypothesis with right or wrong confirmation of this hypothesis from the results, and if this train of thought is reflected in conclusions. So if you do see it, you may encourage authors and tell like it's really great, easy to follow, or if it is missing, you may write down like this writing could be too technical or even boring. Do not hesitate to give strong feedback, because it's all friendly audience, and it is a help to overcome resistance of big life reviewers in the future. Do you see from the what is written in discussion section trend between conditions of the simulations and how the results are affected? Okay. So, did anyone completed reading of discussion section by London? Fatima, would you like to comment and present? Can you bring it in and show him?
So first, briefly write using your words what this paper is about. So what I understand here is that ground state electronic structure calculation in the presence of electric field, but the model is absent.
What's that?
What is the model here? Thank you.
Oh, you're suggesting to treat a reader as a baby who doesn't remember what was on the previous page and remind, like, as
Oh,
you, as
okay,
you,
yeah.
no, I like this idea. I'm trying to do the same. Like, you may have forgotten that on 2 pages ago we defined that this model consists of something. It's not bad. Okay.
So question number 1, does author focused on the discussion of the results after the brief description? I don't think so.
Okay.
So only what I understand here, you discussed mainly about computational problem. No discussion on weakness or strengths of your methods or results. That's what I understand. So I'm not sure. Like I might be wrong. Okay. So, and question number 2. Physical process, I don't know. I can understand that electronic properties with different electric field you study, right? And then, does author identify list of conditions? Yes, different strengths of different strengths of electric field. Yeah, like you put different values of electric field and see what happened, right?
Yeah. Well, yeah. Because basically, I was just trying to get it to work, and it wasn't. So I was just trying all sorts of stuff just to see if anything worked.
And question number 4, does author identify any hypothesis, right, wrong, based on computed data? I have no comments on question 5 as well. And for question 6, yes, qualitative change when you put different magnitudes of electric field. I mean, different values of magnetic field. So of course, it's a vector of magnetic field. So that's what.
Okay.
I have written.
Yeah. Thank you much. Thank you much. Do you want to comment?
So I guess my first impression is this kind of discussion reads like a report for the group instead of for the paper. So of course there are lots of stuff about technical details.
Yeah.
And for the second paragraph, I guess I don't understand. Is there any changes for the electronic structure after you add in that electric field?
No. So basically, I would run the optimization without an electric field, and then I would impose an electric field and rerun the optimization, and it would just finish immediately. Like it would only take 2 or 3 ionic steps, and it would just be done.
But
So
how about the orbital occupation? Does it changes?
No
The
changes.
band gap
It's-
of
I mean, there like 0.0001 eV differences in certain areas, but there's effectively no difference at all.
okay. Did you try to search literature to see if anyone done something?
I wasn't able to find anything or figure anything out to make it not just fail. I don't know.
Because in the paper you said there might be some incorrect parameters, right? So
I mean, that's my guess, is that I'm just doing something dumb and it's just not working. But, I mean, I've tried so many different things that it might just be a bug in VASP, I don't know.
Did you try different versions or different implementations compared to different systems?
No, well, I mean,
Like,
I did Edison and Corey, I guess, but
there is
beyond
also
that, I don't know.
a version of Thunder, Raspberry Thunder, and there was a Raspberry Photo, which is a little pathetic for big systems, but okay, try to comparison.
And last question is for molecular dynamics. So why you do molecular dynamics? Is it a basis for non-adiabatic coupling calculations?
Let's say that again.
So why you do molecular dynamics calculations?
To try to calculate basically the changes in the density matrix. Basically do the same thing that I did with the previous stuff, except instead of changing out ligands, I'm changing an electric field.
So find non-adiabatic couples.
Yeah.
Then is it necessary to include electrical field in molecular dynamics calculations? Do you expect there are significant changes in the atom positions?
No, but the fact that if I was running heating or molecular dynamics, that it would just, every single time it would fail on the second ionic step, suggests that there's something definitely not going right with the implementation of the electric field. Because no matter what I did, it was just the second step, it just fails every time. So I was able to kind of cheat around that, but it still is probably not trustable.
And on itself, this question that Brandon posed as a byproduct, it is really cool. It's like whether presence of electric field will affect non-adiabatic couplings. Because strong field will not, big field will just adjust energies. A strong field will change shapes of orbitals and therefore will change their overlaps. So it's an interesting question, even if everything will work perfectly.
Okay.
I don't know how I will deliver a lecture in this audience with blinking screen. Oh, so like reading this masterpiece from the beginning, the effect of an electric field obtained through VASP calculations are not trustworthy. I would edit it right away without telling that it is keeping the doubts, but like precision of effects or qualitative trends, more specific, not effects, but precision or trends. And not trustworthy was significantly limited from the point of view of authors, right? We do not know, maybe someone would like it. It's just verbal way. So before, or maybe right after this line, which could be a good summary to attract attention, when we declare, make a little declaration, because right now, by reading, like if we wouldn't attend presentations by London and if we wouldn't look at his poster, we may look that he's just trying to fight VASP and see if it is able to compute something reasonable with electric field. But there is an important declaration missed, that effect of electric field was taken into account by two complementary approaches. First by literal use of constrained DFT implemented in specific software, and second by combining unperturbed ground state DFT with account of electric field by perturbation theory. And the whole paper could be formulated as comparison, like at least, at most, if all results would be perfect, paper could be formulated as comparison of these two approaches. Now, after this declaration, for the whole this big paragraph, one can take in approach A, and then keep going and analyzing. And at the end, one would need to tell what happened in approach B, because it is actually what was performed. So for the first part, where electric field is blindly input into DFT as a parameter. Like VASP is a software that implements DFT with some constrained DFT procedure. Is there a term in DFT that procedure that includes electric field? Maybe it is included or will be included in the methods section that one may refer there. Now, the electric field turned was behaving suspicious. Which figure or table illustrates that it is suspicious? Which evidence? Is it just words, or there is figure in result that looks strange? I'm not asking it. It's just observation as a reviewer. You may or may not take it into account. For ground state, like energy with electric field energy. So maybe it was reported in some table, and it is a good place to refer to this table. If it is not the best or most interesting result, maybe it is in supporting information. But if it is not mentioned in the results, then why discuss it? FOPT.
I thought I'd find that like really first order perturbation theory. I might have deleted that one.
Yeah, but for not it may be not a common abbreviation for everyone.
Right. I just didn't want to type it out a bunch of times.
Regime consistently achieved convergence in 5 ionic steps. It's just know that maybe orbitals were different if you put electric field. Maybe not. Again, it's maybe too late to add more calculations, but it's always curiosity. Also, not as new calculations, but as a thought. Is there a way to mimic electric field in the maybe in the third way, not by perturbation theory and not by explicit parameter, but maybe putting point charges, like an ion that would take oxidation as cation and anion, freeze them above and below surface, and assume that they will create electric field. I saw papers where people doing it because it is more trustable than putting electric field. It could be too late to redo things, but you may mention it as an opportunity. And at the end of this analysis of approach A, again, assuming that no calculations will be done from now on, but from the point of view of authors, is there evidence to blame general implementation of electric field in DFT procedure, or it is only specific compilation or specific version? So is it like general problem or just particular way? Maybe no. I'm not asking. I'm just mentioning. One can, even without answer, one can write. We are not sure if it is general problem for all implementations or the particular one that we explored. Now, for the approach B, well, what is good, what is bad? Is it justified to trim the perturbation with only the first term. What is missed if one is not including higher order term? Generally, what is criterion to comparing like approach A and approach B? Right now, maybe it is not helpful to compare them because you're telling that approach A gives some garbage. But if everything will be perfect, which criterion, which observable, which numerical quantity would make their convergence? And as Fatima mentioned, and you will also mentioned that right now it looks a little technical, right? And you may brag by breadth of your thoughts in discussion, even if results do not allow it. So just depart from technical questions and share thoughts like what was the potential main applied challenge that makes this calculation necessary. So we did a little interview on how electric field affects charge rate, whether it makes electric field may charge transfer slower or quicker, or maybe it completely shuts it off or speeds make it more efficient. So either to which extent the computed computations address this challenge. Right now you are telling that approach A with blind implementation in WASP doesn't show much correlation between electric field and any parameters. And for B probably there are more rich results, which also have doubts in their applicability, but it can be, this like place can be viewed. And if one wants to find reviewers need help. Reviewers are lazy and they do not have time mostly, and if you want positive review, there is nothing wrong to give them an opportunity to say good things about your work just by putting your words in their mouth and tell like you may observe different things, but there are also good something good about this work. So some intuitive expectations did match calculations. Like for approach A was nothing, but for approach B, there was a trend that by changing electric field, one increases or decreases band gap, right? And it's really good expectation to observation that matches intuitive expectations. It's a positive feature of this work, and it is nothing wrong to highlight. Well, too technical. Problems with software. Hypothesis right or wrong. One may add that this calculation was done in order to find if electric field speeds up or slows down charge transfer. It can be like, as Fatima suggested, to remind reader what is the system. One can also remind reader and reviewer what was the main question, and no one will blame author if this main question will be repeated at the beginning of introduction, at the beginning of results, and at the beginning of discussion. So like, finally, did we found that the electric field slows down or speeds up transfer? And I don't know if it is right or wrong. I was writing it in a rush, but by tuning electric field, one can modify gap in a broad range from 0 to very broad. So in some sense, maybe one can interpret it as material is tuned from being metal to semiconductor, at least for. I'm not sure if it is the right thing to say, but from what you see from perturbation theory, you can do it. more comments about work of London. So the idea is that we all try to implement some feedback when in whatever time we draft of the overall paper is open. Do you have feedback you use?
I guess just like, yeah, just grammar and stuff.
Do you have anything about maybe you
Not a lot of comments on text, just some grammar stuff. I don't know, it seems outlined pretty well. Main takeaway is trying to improve chemical and colloidal stability and photophysical properties of these materials. And you mentioned we're playing to the strengths that you see spontaneous ligand absorption due to exothermic reaction, and not a lot of comments on the photophysical properties, but I just assume you're still working on them at this point, so yeah,
Okay.
that's fine.
Yeah, thanks for bringing it up.
Basically, I just looking for a precursor to make the surface protect the surface and at least maintain the optical properties. Did a fairly good job going and actually talking about your results. Although I'm assuming that you're still working on these two sections.
Okay, yeah, that's good. What do you have? Sure.
So, Yunus' discussion looks pretty good to me. So I have a small thing here. This first paragraph looks like motivation to me. And then, so what I understand from these studies is that he tried to make a protective layer of benzene diazonium bromide on silicon surface, and then he studied optical and electronic properties of that protective silicon surface. And question number 1. I can see author focused on the discussion of results after the description. So the physical, what I understand. What I understand here, the physical process is a chemisorption of phenyl groups on silicon surface. Then the list of conditions which may affect the main result, incorrect band gap, and a K point represented by gamma point only. And the hypothesis, the diazonium to phenyl transformation is exothermic. That's what I understand. And connection or correlation between any conditions of the simulation, like examples, I'm not sure. And finally, the qualitative change of the system. So if the solvent is not treated explicitly, then error might come. And that is missing the polarization of media. That's all.
Okay. Yeah. Thank you, Mitch.
So I guess when you mentioned the critical size of the nanowires, from the context it sounds like you're talking about the diameter, but I'm not 100% sure. It is actually the diameter that you're talking about there, right? Okay. The sentence that I circled here, I guess I was a little, I don't know anything about the Van Hoff singularity, so I just didn't really follow it particularly well.
So you suggest to treat readers as kids and provide definition just in case if someone has forgotten.
Yeah, I suppose.
Okay. Yeah, that's always good.
And then at the bottom, you mentioned something being smaller. Oh yeah, you mentioned that the choice of the functional has a smaller effect in crystalline silicon. Are you saying that it's smaller in crystalline silicon than in silicon nanowires, or I guess what do you?
I think this is kind of messy.
But crystalline, like you mean bulk? Crystalline bulk versus nanowire confined, or crystalline versus amorphous?
Okay. Yeah, because I just wasn't sure what you were comparing crystalline silicon to. That's all I have on that.
Okay, yeah, thank you.
So basically, my comment is, I'm really not sure what your paper is about from this discussion. You give a nice overview here, but it really doesn't explain what you're actually trying to figure out or working on or doing.
That's it?
Pretty much.
I guess the first question here is, you talk about absorption with silicon nanowire, and you also mentioned lifetime of hard carriers. So what's the connection?
So as I interpreted this criticism, it doesn't mean that this idea is wrong. It means that it needs to be defined in more details, like for kids. And explain what is the connection.
Yeah, I think so if one wants to make silicon nanowire less than 10 nanometer, oxidation is required, and I think I missed what's the effect of oxidation here. That's what I missed.
And you talk about some singularity and this kind of factor. But I guess you already mentioned this in your previous paper, right? So why you need to repeat it here? I guess maybe you should focus on emission and also quantum yields.
Again, it doesn't mean that it is wrong or it doesn't need to be there, but define and mention connection. Like for singularity, like peaks in the density of states and absorption, and then maybe because of this one-dimensional features, one expects very sharp peaks in absorption and emission. Huh?
Here I just wrote shortly.
That's okay. We still have. That's it. Okay. Yeah. Thank you. So, anyone wants to speak about work by who is missing today? Yes. Anything, or I can just collect and scan it first. Okay. So, thank you much for investing your time into this activity. And what do we have? Daniel will ask either Aaron or London to substitute him in on the conference, because he's not going, and you can either show his work. It will be oral. He will just provide slides, but since he will not be able to control, you can, and if you are not ready to talk about his work, you can show his part for 5 minutes, and then. But there is much more interesting thing. My own results. It's completely fine. I don't know whom he will choose and whom he will.
This presentation is an oral presentation?
Yes.
That's not a poster?
No. But it's another chance for a glory, right? And I do not want to intervene. It's his problem to ask either one of you. I cannot support before he chooses. On Friday, please prepare to present your practice talks. Right? We will do it. We'll plan for like 3 p.m., but maybe there will be last-minute changes, or if you prefer some other time, just let me know ahead of. So we'll do it. We'll present for whatever it takes in real life and collect some questions for improvements.
So with the 15-minute time slots, should we plan for 12 minutes to talk, 3?
Bless you, bless you, bless you. It's okay. It is your free choice. If you really want feedback and questions, you speak for 12 minutes and leave 3 minutes for questions. If you want to shut up any questions, you just talk until the until the chair stops you. Like if you're not confident what to answer, you just keep talking until you're getting stopped. And those who are not traveling may meet next week, but in the whole group will meet only in 2 weeks. So please plan to complete, or at least contribute to completion of introduction section. So it is less creative than discussion. You just mention your goal and what interesting is in the literature. And if you do not have EndNote software, or if you're writing LaTeX, you can keep doing BibTeX, but please contact me, because with EndNote it is like 20 times more efficient. Okay, meeting is dismissed. In this room there will be next generation of computational chemists lectures soon.